Welcome back, engineers. In the previous video, we saw a demo about how transport layer protocols work. We used Wireshark and did some packet sniffing, and we saw what data we could find, right? In this video, let's go into application layer protocols and we'll see a demo about how HTTP 1, 2, and 3 work. Okay, I hope you're ready. Let's get started. So this demo as well is going to be really simple. We're going to use Python servers and we're going to use different libraries to deal with HTTP1 interface, HTTP2 interface, HTTP3 interface, and we're going to make use of some open SSL for generating the certificates that we'll require for doing HTTPS. Okay, so let's see how it goes. So for first one, we're going to do a demo of HTTP1. We just need to install Flask, which I've already done. We'll just start the server. First, I'm going to show you how the server looks like, what we can do with it, and then we'll see the code. So my server is running now. Let's go into localhost. Now this is a quick demo with a UI element to it. And if we remember, we discussed that one of the drawbacks of HTTP1 was that it was having a head of line blocking, right? So for a single connection, I'm not able to request multiple assets or multiple requests. So this demo is particularly showcasing that. So we are running on HTTP1 and we're going to make two requests, one with a fast request, which is responding very fast, one with a slow request, which will wait for 5 seconds before responding, right? So these are two independent requests that I'm sending, and we can see that it takes about 5 seconds gap before sending a success response. Now, if I were to send both requests in the same connection, so one connection, two requests, slow and fast. So this is what it is. So we are requesting at 5:51 p.m. both slow and fast, and if you observe, we have received both responses at 5:53, which means that the faster response, which could have been instant, was blocked because of HOL blocking issue in HTTP1, right? So we will do the same demo with HTTP2 and 3, and we will see that there is no blocking issue, and that is the concept of multiplexing, right? So another thing to notice is this is HTTP localhost 8081. It is not running on any HTTPS. So if we were to inspect it on Wireshark, let's clear all this and let's try to hit our demo again. So we can see the typical TCP handshake going on with sync acknowledgement packets, and we are actually sending the data. We can actually see some of the HTML here. So if we go to follow TCP stream, we can actually see the data that was being sent, right? It was just a simple HTML, page was delayed by 5 seconds, right? So because it is not using any HTTPS, we were able to see this data. And as you can see, the requests are completed. We have the finished acknowledgements as well, right? So this is how HTTP1 works. It uses TCP underneath. And now let's look at the code. So we'll go to HTTP1 server. It's a simple code. I'll just stop the server here. It's a simple code of a Flask server. We have made use of a simple Flask server here, and we did 3 routes. So we have the index route, which gives the whole layout about calling the request, and then we have a slow route, which is waiting for 5 seconds before finishing, and then we have the fast route, which is just finishing super fast, right? And everybody is returning a simple HTML that we are just rendering onto the page, right? And we are just running it on port 8081. So if we look at the main route, this is again a simple HTML with some styling, and then there are buttons to actually make the request. So if we see here, on click, we are making two things: fetch slow and fetch fast. These are the individual buttons which we could use to make individual calls to fast and slow. And then there is a third button which is making two calls at the same time, right? So this is a fetch/slow, which is making the call and waiting for this response. And then we have set timeout for just 100 milliseconds. So after the slow request is called, we wait for 100 milliseconds and make the fast request. So now both of them are in the same TCP connection and they are waiting for the response. And because of HTTP1's head of line blocking issue, this fast is blocked because the slow is waiting for 5 seconds before it can respond, right? So that's the issue with HTTP1. Now we're going to do a demo on HTTP2 and see that this issue does not occur. So for HTTP2, we're going to use hypercon, and we're going to generate some certificates using OpenSSL because HTTP2 requires it to be a secure connection and requires HTTPS. So we're going to create some certificates, just give some dummy data here, and these files are refreshed, cert.pem and key.pem, right? Now we are able to launch the server using this command. So this is a hypercon server, and it is just binding this HTTP2 server app to HTTP server 2 app to 8081 port, right? So let's launch it. Now this time this is going to be HTTPS because we have used certificates and our server is running. Now let's launch and see. This time we're going to use HTTPS localhost 8081. Now because I'm using local certificates, we just need to let the browser know that these are fine, we accept the risk, and it is able to render them. Now if you see here, this is actually HTTPS. It is complaining that it is not secure because of the local certificates. Now let's see how it goes. So this is HTTP2 non-blocking demo. So we have the same code, and if we see here, we received response from fast, it was not blocked, and now we receive the response from slow. So 556.53 is when we received response from fast, and 58 is when we received response from slow. So even though the slow request is waiting for 5 seconds, it is not blocking the fast request. So this is what is an improvement over HTTP1. So this is called multiplexing. So in the same connection, we're able to do multiple requests, and because of this, we are able to receive the fast one first, followed by the slow one. They're not blocking each other. And because this is using HTTPS, we should not be able to see any data here. So let's clear all this and let's make a new request. Let's just listen to everything here. Right. So if we see here, we are sending the data again using TCP because we are still in HTTP2, and we are sending the application data, but we are not able to actually see the data because it is encrypted. We can go through all these messages and nowhere will be able to see the actual data because it is encrypted. So just because we have used the OpenSSL certificates, we are able to encrypt the data so that nobody in the middle can inspect and see our data. So what are these certificates, cert-pem, key-pem? How are they making it secure? How is this encryption happening is something we will discuss in a future video where we are discussing the concepts of encryption and cryptography. But for now, let's understand that because of these certificates, nobody can inspect and sniff our data and take the data that we're actually sending, right? So that's how HTTP2 works. Now let's close this and go to HTTP3. Now for HTTP3, we're going to make use of AIO QUIC because HTTP3 runs on UDP and QUIC, right? So for this, again, we're just going to generate new certificates just to be sure. So this is again HTTPS protocol, and we're going to run hypercon again, but this time we're going to bind HTTP3 server with 8081, and we are going to do QUIC bind. This is again a required step to bind this HTTP server to both TCP and UDP, because if UDP is not available, it's going to fall back to TCP, which means that if HTTP3 is not available, it's going to fall back to HTTP2, right? And complete the request using TCP. So let's see. So we're going to launch the server. The server is running fine now. And let's go here and launch this. Again, we are seeing this error because of local certificates. We can accept the risk. Now this is HTTP3 QUIC no blocking demo, and let's run and see. So first step is to see that it works and there is no head of line blocking, which means that our fast request was not blocked, right? Which is very good to see. So it supports multiplexing. Another thing is it is HTTPS. Again, if we were to inspect it in Wireshark, we would see a lot of things about TCP v1.3, but we wouldn't be able to see any data that we have sent, right? So it is secure. However, if you were to see in the network tab, we should see the protocol HTTP3, but in Firefox, we would see HTTP2 because Firefox is trying to use HTTP2 and it is falling back to TCP/IP and HTTP2. But if we were to do the same thing on Safari, I'll just quickly refresh it here. We'll accept the request, the certificates, and now we have HTTP3 demo running here, the same localhost 8081 HTTPS. And now if we run the request for non-blocking demo, here we can see that it is using HTTP3, right? So this is what we need. So it depends on the browser. If the browser is able to support HTTP3 by default, it will do that. Otherwise, it will fall back to TCP/IP and not HTTP3. So if we were to go back to Wireshark and do this again, let's clear all this. Let's go to Safari and run it again. Now we'll see that the protocol is now UDP, right? So that's what we need. Now let's look at the code. So for HTTP2 server, again, it was the same code. Just like HTTP1, we have 3 routes: index route, which is having the 3 buttons, and the same code is running here. There are 2 requests being sent, fast and slow, with 100 milliseconds gap, and we can see that there is no head of line blocking. Similarly for HTTP3, we have a similar code where we have 1 button which is triggering both these requests. Again, we don't have head of line blocking in this, and it also supports HTTP3, and it also uses UDP, which is extremely fast, right? So these are some of the features I wanted to demo to you guys. I don't think there is any demo like this available on the internet anywhere. So if you appreciate it, definitely leave me a like. I would be very grateful. Thank you so much for watching. In the next video, we will continue with the next topics in system design. Stay subscribed and do subscribe if you haven't done already so that you don't miss out on any future videos. Thank you so much for watching. I will see you in the next one. Cheers.